Hello everyone. Can you hear me?
Yes, we can hear you.
Okay. Let's start. First presentation. Dear Güneş. Dear Güneş.
Hello.
Hello. You can start.
Okay. My parents, Emre, are going to present it. Okay.
Okay.
Emre Aydemir.
Okay.
Hello, ben Türkçe olacak diye düşünmüştüm ama
Türkçe sunabilirsiniz. Problem yok.
Türkçe sunabilirsem problem yok benim için de.
Tamam.
Tamamdır. Hemen sunumu paylaşıp birazdan başlayacağım. Hemen geliyor. Ekran geldi değil mi?
Geldi. Problem yok.
Tamamdır. Ben Yalova Üniversitesi Bilgisayar Mühendisliği mezunuyum. İsmim Emre Aydemir. Günümüzde mobil cihazların kullanımıyla hemen başlayayım mı slayta, sunuma? Önce şeyini alayım.
Başlayabilirsiniz.
Tamamdır. Günümüzde mobil cihazların kullanımıyla birlikte farklı ihtiyaçlar ortaya çıkmıştır. Bunlardan biri cihazla konuşabilmek, cihazla konuşarak bir şeyler yaptırmaktır. Bu işleve sahip yazılımlara sanal asistan, chatbot denilmektedir. Bu araştırma çalışmasında da geliştirmiş olduğu sanal asistan yazılımından bahsedeceğim. Popüler sanal asistan yazılımlarından bahsederek devam etmek gerekirse Siri, Google, Cortana, Alexa gibi yazılımlar bunlara örnek verilebilir. Bunların çalışma prensipleri genellikle kullanıcının ne dediği NLU yani doğal dil anlama teknikleriyle anlaşılmaktadır. Biz bu popüler yazılımlardan farklı olarak kullanıcının ne dediğini düzenli ifadeler yani regular expressions kullanarak anlayabildik. Regular expressions nedir? Genellikle verilen metin içerisindeki örüntülerin tespitinde kullanılan, günümüzde de e-posta, telefon adresi gibi şeylerin tespitinde sıklıkla kullanılan bir yöntemdir. Biz de sanal asistan yazılımımızda kullanıcının ne dediğinin anlaşılmasında, hangi diyalog söylenecek onun tespitinde düzenli ifadeler kullandık. Geliştirdiğimiz sanal asistan yazılımından bahsetmek gerekirse, diyalog model sistemi olarak adlandırdığım, kendi geliştirdiğim bir model, diyalog model sistemiyle çalışmaktadır. Çalışma prensibi temel olarak şöyledir. Sistem içerisinde tanımlı diyalogların olduğu bir liste bulunmaktadır. Liste içerisinde bulunan diyalogların her birinin kendine ait regex örüntüsü yani düzenli ifadeler örüntüsü bulunmaktadır. Kullanıcının sesli söyledikleri metne dönüştürücü bir yazılım metne dönüştürdükten sonra metne diyalog örüntüsü uyan diyaloğun cevap metni sese dönüştürülerek çalıştırılır. Kullanıcıya cevap vermesi sağlanır. Diyaloglar bu sistemde art arda eklenebilir. Yandaki konuşma diyaloğu gibi geliştirilen sisteme kolayca bir şekilde eklenebilmektedir. Burada gördüğünüz üzere mesaj at, kime mesaj atayım diye asistan bir diyalog senaryosu ortaya çıkarmış. Burada kolay bir şekilde biz geliştirdiğimiz diyalog model sistemi ekleyebiliyoruz. Diyalog model sistemi yapısından bahsetmek gerekirse, bir parent modelin 3 adet kalıtım alan model bulunmaktadır. Birincisi diyalog model. Sistem içerisinde tutulan diyalogların geneli diyalog modelde tutulmaktadır. Burada diyaloğun kendine ait düzenli ifadeler örüntüsü bulunmaktadır. Bu düzenli ifadeler örüntüsüyle bu diyaloğun çalıştırılıp çalıştırılmayacağı anlaşılmaktadır. İçerisinde kendinden sonra gelecek diyalogları tutmaktadır. Ya da rastgele cevap verecekse rastgele cevapları tutmaktadır. Diyalog seçici diyalogumuz. Burada örnek vermek gerekirse selector fonksiyonu bulunmakta. Burada selector fonksiyonu kullanımına örnek vermek gerekirse farklı zaman dilimlerinde kullanıcıya farklı cevaplar verebilme özelliği örnek verilebilir. Örneğin akşam merhaba denildiğinde akşamsa iyi akşamlar diyebilir, öğlense iyi öğlenler diyebilir. Bu şekilde diyalog selektör kullanabilir. Rastgele diyalog seçici. Burada da çeşitliliği arttırmak için yazılmış bir diyalog bu. İçerisine farklı diyaloglar konulmuştur. Mesela beni eğlendir dediğinde kullanıcı farklı oyunlar sunabilir. Bu şekilde diyaloglar gösterebilir. Diyalog eylemleri gösterebilir. Yanda gördüğünüz gibi diyaloglar bir senaryo gibi alt alta yazılmış. Kolay bir şekilde eklenebiliyor. Burada her bir diyaloğun kendine ait regex örüntüsü ve buna karşılık gelen diyalogların girilmesi yeterlidir. Yapılan uygulamadan ekranlar ve diyaloglar göstermek gerekirse, geliştirilen uygulama Flutter'la geliştirilmiştir. Google tarafından oluşturulan açık kaynaklı bir yazılım geliştirme kitidir. Android, iOS, Windows, Mac, Linux ve Web için uygulamalar geliştirmek için kullanılıyor. Burada da işte o multi platform, çoklu platform desteği vermek için kullanıcılara böyle bir geliştirme kiti kullandık. Geliştirdiğimiz arayüzün basit ve kullanıcı dostu olmasına dikkat ettik. Burada ekranlardan uygulamanın işleyiş yapısını bahsetmek gerekirse, kullanıcı 16.50'ye alarm kur dendiğinde alarm kurmak için tanımlı diyalog çalıştırır. Bu regex düzenli ifadeler yardımıyla gerçekleşiyor. Aynı zamanda yazdığımız diyalog model sistemiyle çalışıyor. Dakika ve saat bilgisi yine aynı şekilde düzenli ifadelerle kolay bir şekilde çekilebilmiştir. Ona göre alarm kurmuştur. Kullanıcıya yardımcı olmuştur. Sağda yine aynı şekilde 5 ile 63 arasında rastgele bir sayı tut diyaloğu bulunmakta. Burada da 5'i ve 63'ü alabiliyor düzenli ifadeler yardımıyla. Ona göre rastgele sayı gösterebiliyor. Annemi ara dediğinde az önce bahsettiğimiz diyalog sisteminde bulunan diyalog selektör yardımı ile rehberde annem kişisinin olup olmadığını denetliyor. Yoksa arama motoru üzerinden arama yapıyor. Varsa annem kişisini arıyor. Sağda eğer diyalog model sisteminde tanımlanmamış bir diyalog bulunmaktaysa, yani kullanıcıya boş bir cevap vermek yerine arama motorunda arayıp bunun sonucunu döndürüyor. Matematiksel işlemler yapılabiliyor. Yine kullanıcının dediği şey içerisinde matematiksel işlemleri algılayabiliyor. Ona göre hesap sunabiliyor. Yani 5 kere 10 üstü 2 matematiksel işleme dönüştürüp ona göre kullanıcıya işlem sonucunu döndürmüş. Burada nasıl yapıldığını anlatmışız. Regex örüntüsünde D artı soru işareti gün şeklinde yazmışız. Bu şekilde alınabiliyor. Gün, saat, dakika bunlar düzenli ifadeler yardımıyla yine aynı şekilde alabilirmiş. Ve geliştirdiğimiz sanal asistan yazılımına daha birçok diyalog eklenecektir. Eklenmeye de devam edecektir. Bu araştırma çalışması süresince düzenli ifadelerin ve geliştirilen diyalog model sisteminin sanal asistan yazılımını kolaylaştırdığı görülmüştür. Daha fazla geliştirilir ve daha fazla özellik eklenirse popüler sanal asistan yazılımlarına yakınlaşılabilir, düzeye gelebilir. Geliştirilen sanal asistan için yapılması planlanan birkaç özellik düşünüyoruz. Farklı sanal asistan kişilikleri yazılması daha eğlenceli olabilir. Kullanıcıya daha eğlenceli kişilikler sunabilir. Nesnelerin internetiyle çalışabilirlik. Örneğin bir ışığı aç kapa dediğinizde ışığı aç kapa eylemi gerçekleştirdi. Bu günümüzde popüler sanal asistan yazılımlarının çoğunda bulunuyor. Bizde neden olmasın? Kullanıcının kendi diyaloglarını ekleyebilmesi de eklenebilecek özelliklere örnek olarak verilebilir. Benim anlatacaklarım bu kadardı. Beni dinlediğiniz için teşekkür ederim. Sorularınız varsa alabilirim.
Evet, sunum için teşekkürler.
Ben teşekkür ederim.
Sanırım soru yok.
Tamam.
Okay, next presentation. Dear Muhammed Reza.
Yes. Yes, thank you very much. Okay.
Okay.
Yes, sorry, let me share my screen, okay?
Yeah.
Guys, okay, wait. Okay, doctor, let me.
Okay.
Okay, hello everyone. If my screen is shared, you can see our paper is about the Alzheimer's disease detection by applying the Chebyshev moments followed by the genetic algorithms. And this paper is somehow based on about the application of computer-aided tools and artificial intelligence in the Alzheimer, in the medical applications. As you see, our paper is consists of some chapters, introductions, proposed method, and into the proposed method, we will discuss about the data set. First of all, feature extraction based on Chebyshev moments. And after that, we improve the feature extractions stage by adding the feature selections using the genetic algorithms. And then we will have a classification and metrics. Finally, we discuss about the result and discussions and the conclusion. Okay, first, let's have an introductions. Alzheimer's disease or AD is one of the most important or most common brain disorder. It's related to the problems with the brain activity. And one thing that is important about this disease is that the early detection of Alzheimer's disease can be so important or crucial for the next treatments. So if we can somehow detect the Alzheimer's diseases, not only if we can, for example, treat someone is important, we call that detection AD against healthy or healthy control subjects, but also if we can somehow understand the someone has this disease, but in the early period of time, before it is too late, we call that early cognitive impairment or MCI. So this can be so important and useful. In other hands, machine learning approaches or algorithms help medical science in very different aspects. One of them is here. So like other field of engineering and medical, the machine learnings can help us for distinguishing between the different subjects of this thesis. The basic of the detection by the machine learnings is like this. First of all, we input images to the some algorithms or approaches. From the images, we consider some features for every image, and the classification algorithms like as SVM or even neural networks, the deep learnings, based on the extract features, can predict the next type of images and give us the accuracy and some other metrics to let us know if the test subject have the, for example, is similar to the HC or is similar to the AD subjects. But here in this paper, we not only used a new moment methods to extract the features from a picture of a brain, and we call it Chebyshev methods. The Chebyshev methods help us to extract some features from the images. And then also we improve that by a genetic algorithms as a materialistic algorithm. So because when we extract features from an image, maybe some of them are irrelevant. So not only increase the cost of our computations, but also it's decrease in our accuracy. If we can somehow just extract and select the optimized or the most important and most effective features, which can be done that by genetic algorithms, it's really help our actually classifier. It helps our classifier to classifications these subjects by more accuracy. So we apply genetic algorithms after the Chebyshev moments. Also, for the classification task, we use the SVM using a tenfold cross-validation technique to distinguish not only AD to HC, but also MCI by SC and also AD to MCI. So this is our proposed method. We have the input data. They are gathered from SMRI images. MRI is one of the most commonly used technologies to have the picture from the brain. After that, it is necessary, as is common, we should have a pre-processing step because we should eliminate some noises, or we should do normalization and some other tasks. After that, we have the feature extractions, that there are a lot of features extraction methods. We use Chebyshev moment, and we compare, of course, with other Chebyshev, other moments and other extractions, feature extractions methods, our result. So we one time, without using genetic algorithms or utilizing that, we give the output of the feature extraction of Chebyshev moments to the SVM classifier, and another time we use genetic algorithms, and we saw the result of the after selecting the most effective features, and we compare all of them together. Of course, in all the classification steps, we have both test and we have both training sections. Means that we divided our data to 90% for training, and then we apply the method result to the other 10% of test data set. Okay, in our method, we use the data set These are the details for the data set about the age, gender, MMSE, and others informations. And it can be online, can be downloaded into the ADNI. ADNI is a very famous website about the Alzheimer disease databases. So they are free, open source, and also after the data, we use the pre-processing in MATLAB with the software SPM number 12. After that, we applied the feature extraction based on Chebyshev moments. You know, Chebyshev moments is one of the moments methods. Moments methods extract a lot of features, like there are some kind of transfer functions. These are the formula for the Chebyshev moment. You can see we can check the order depending on the value of P and Q. We extract a lot of information. You know, for example, for one image, we may have, for a 3D image, for example, we can have 256 multiplied 256 multiplied 256 pixels or features usually. So these are a lot of features. It's not possible to be analyze them or somehow to work on them. There are a lot of features. So when we apply some other features such as wavelets or even Zernike moments, or here in our paper Chebyshev moments, we can extract just a little number of features to decide it using them. Even after the Chebyshev moments, we applied another materialist algorithm because it is somehow nonlinear and somehow NP-hard problem, because we extracted 78 features from all the features of an image. But even we want to try among all these 78 features after Chebyshev moment, which features can be selected or which features are more effective. So we defined genetic algorithms. As you know, genetic algorithms are one of the approximately the most generation-based materialistic algorithms. We randomly generate a new generation, but they improve all the possible states or the populations based on its operations, which are mutation, crossover, and selection methods. And also, we should consider a fitness function for the genetic algorithms. Here, we decided to consider a multi-objective fitness function for the as a fitness function of the genetic algorithms, because what was important for us, both options were important for us. First of all, we decided to increase the accuracy, and at the same time, we decided we prefer to do and achieve the higher accuracy using a lower number of features. So we used this multi-objective function for the genetic algorithms, of course, because we should balance between them. We use two parameters, K1 and K2. K1 can control, for example, bigger K1 lets the genetic algorithms to search for more accuracy. And for K2, bigger value lets the genetic algorithms to search for less number of features. And these are the parameters. We provided all the information if someone wants to apply that about the genetic algorithms here. Also, what is important for us is the output of the classifications. We have some parameters such as accuracy, sensitivity, and specificity. we can calculate them according to this formula. This shows us how our classification is performed and what is the performance and efficiency of our proposed method. So you can see the result here. First of all, we applied the proposed method to the data set. First, we applied that with just Chebyshev moments, and then one time we applied that with Chebyshev moments with the GR or genetic algorithms. As you see, every result has 3 tables because we applied at the same time to distinguish between Alzheimer's disease and healthy control, or the early detection and HC, and also AD to MCI. You can see in every table using genetic algorithms plus Chebyshev moment has improved somehow the accuracy, because the irrelevant and the effective selected features are used by the classifier. And it's obvious that when we delete the irrelevant features, it can help us to classify that. Of course, you can see the number of features. So the genetic algorithms is able to achieve higher accuracy with the less number of features. This can be so helpful and useful for most of medical science, because they can now understand with these features, that features are from which region maybe, and it is more useful for them. Also, we have done that for different amount of K1 and K2 as our control parameters, because as I told you, when we increase the K1, the algorithms try to find the higher accuracy, but when we increase the K2, the algorithms is search for the less amount of features. These are the result. Also, these are the result when we compare the Chebyshev moment result. Our proposed method means that Chebyshev moment using a genetic algorithms, they are compared with just Chebyshev moments alone. And also we compare that with others famous and well-known feature extraction methods such as ZM, wavelet transformer, and CWT. Not always, but most of the time, our proposed method was better totally. However, you can see, for example, for specificity, sometimes other feature extractions was better than our method in specificity. But in case of accuracy, approximately in all the states, our method was better. Also, we use other different classifiers to evaluate the efficiency of our method, because we ask ourselves, maybe it is done by SVM, and SVM is the most important, the most famous one, have shown its efficiency. But anyway, we applied the other, we test the other actually classifier in the MATLAB. You can see the result, and our results show that yes, based on of course, we didn't compare that with neural networks, just with the other famous one, KNN, and the random forest and decision tree. Sometimes decision tree was somehow comparable with our result, but still SVM was better than them. And here we compare our result with other references in the papers. However, this shows that in AD to HC, our results are comparable with others papers. And of course, it is not so somehow very very good comparison because they use another data, another classification method, or another feature extraction methods just to compare our result with their result. You see that somehow their results are better when they use neural networks. But we have done this somehow acceptable level of accuracy in very low amount of number of features. So for future works, for the example, we can apply this amount of selected features by neural networks to see and compare the result together. And as a conclusion, it is very important to pay attention to this somehow this disease like as AD. It is so important to understand the situation of the patients in the early stage. So the methods that can be detect the people from AD to HC and even the people in the mild and early stage are very important. Computer-based tools can help the medical science in this case. So we applied a machine learning methods. In our method, we used Chebyshev moment as a feature extraction stage, and also a metaheuristic improve the extraction sections by applying and adding genetic algorithms to that. We saw that genetic algorithm was able to choose 16 features among 78 features. And also we used SVM or support vector machines as a classifier. And the results show that this can be a very useful method to not only decrease the features, but also have the acceptable level of accuracy in the data set. Thank you for your attention, everybody. If you have any question, I would be appreciated to answer it. Thank you.
Thank you for presentation.
Yeah, you're welcome. Thank you so much.
Next presentation.
Okay.
Dear Elda Jinnah.
Hello, everyone.
Hello.
It's nice to
You can start.
just let me 1 second, yes, to share my presentation, please.
Okay.
Okay, just a sec. Okay. Okay, good afternoon. We are going to present a paper for the classification of standard fashionist database using deep learning-based CNN algorithms. This paper has a contribution of 3 authors, Admira Jafera, Elda Jinnah, and Luciana Totti. The idea is that the classification of the garments is a challenging aspect, as the garments have several properties and some garments have the same characteristics. So therefore, the problem of separation of the clothes becomes quite complex. With this research, we aim to propose 2 different convolutional neural networks, CNN-C1 and CNN-C2 structures, to make possible to solve the problem for the classification of the clothing images in the fashionist database. The study aims to tackle the modal overfit issue, which is one of the most critical problems with this type of algorithms. So we will propose 2 different convolutional neural networks, as I mentioned, with which we will provide better performance and results from the actual algorithms. We already know that the deep learning has given excellent outcomes in many numerous fields, such as big data, natural language processing, computer vision, and the automated speech recognition. The most common usage of deep neural network is the convolutional neural networks. They can learn high quality details and complex formats for a very vast number of images and offer excellent classification result. However, one of the most difficult problems is the overfitting, since in the fashion division, we have labels that reflect many different types of clothing and they have similar features. Okay, so it has large depths of the garment's categorization. So within this study, we will try to resolve the problem of multi-class fashion classification using the CNNs, and we will tackle mostly the overfit issue. There have been several studies in this field, and we have selected some or a few of them to represent today with you or to share with you. As per Alamat et al., he presented a full evaluation of the deep learning study with the CNNs. As per Shobhit, he suggested an approach for the classification of images of fashion articles. Shuning Shen proposed to use the short-term memory networks in order to develop an algorithm by using the fashionist dataset. And Grishma et al. Presented a method for the classification of the fashion items from the dataset of fashionist. We have discovered that the concept of the NIST fashion classification problem of convolutional by using the two proposed convolutional networks. The methodology that we have used is given in this slide. So we have taken the image classification from the dataset fashionist from Zalandos. It contains a training data of 60,000 images, and we used 10,000 of images for testing. Every image is a 28 by 28 in grayscale, and each image is classified in one of the 10 categories, so with a label from 0 to 9. We have used the Google Colab, which provides a high computational processing. And then we have used Python version 3.8 for building our algorithm. And we have realized, or we have achieved that the time to learn for CNN C1, so the first algorithm that we have proposed, is approximately 12 minutes. And the CNN C2 model is approximately 30 minutes. In the third column, we can see the function standards and the EPCOs that we have used to implement our CNNs. This is the fashionist data set. So we are having 10 categories. We labeled them from 0 to 9, and each of these categories have multiple or enormous number of images. The architecture of CNN that we have proposed is categorized in 3 different blocks. We have the feature detection block in the beginning. Then we have the transition block. And finally, we have the classification block. In the first block, so the feature detection block, the layers from Keras are imported, and the Con2DI layer is used to deal with images with the activation function ReLU and mentioning the input shape 2828 and 1 In the transition block, we use the flatten function to convert the input from matrix to arrays, again with the input shape 2828. And the final block, which is the classification block, is made of 2 functions. The first function is to provide the classification, and the second one is applied to finalize the output through the softmax function. In more details, this is the first model architecture. So what are the layers that we have used, their output shape, and the parameters that we have set. So if anyone would like to try, you have the chance of it. And here we have the second proposal model, so CNN C2. In the second model, we have used multiple batch normalization layers to make the function, or to make the algorithm more accurate and higher, more desired outputs. In the slide that you're looking now, we have some results, what is happening within our algorithm. And with the CNN C1, we have achieved an accuracy for the output from the 69% up to 95% for the training data, and we have an accuracy for the testing data from 69% to 89%. So we can say that we have achieved our goal, but still the overfitting is available because we have a non-linear output, and the range of accuracies is not as satisfactory as we wish. If we move on to the second algorithm, CNN C2, we have a much larger accuracy, in fact, so it moves from 95.9% to 98% from the training data, and it has a 92.8 up to 93.1% for the testing data. So the range of the accuracy is very narrow, and of course it's quite high in percentage. We can say that it's much higher than most of the algorithms that are already used nowadays. And whatever I said in the previous slides is also given here in a tabular format for comparison. So as a conclusion, we have proposed 2 new algorithms for overfitting problem in the fashion industry data set. And we say that with the increase of the deep learning methods, the image classification and recognition is improved with the CNNs. From the evaluation, the details of the training algorithm are dependent on a variety of factors, such as data features, optimizers, convolutional layers, step size, and network parameters. And we have achieved it by laying out the convolutional layers and the appropriate quantity of the batch normalization. Now we have added several levels of batch normalization to do so, and the dropouts in place of the fully connected layers throughout the training phase of the CNN C2 network. This is what I had prepared for today. Thank you very much for your attention, and if there is any question, we'd be glad to answer.
Thank you for presentation. Is there a question? Okay, next presentation. Dear Dilibal.
Hello. Currently, I'm having some troubles with my internet. Can I present last for now?
Okay.
Thank you for your understanding.
Okay. Dear Nabil. Dear Mehmet Karahan.
Hello, I am here.
Okay, you can start.
Okay. Can you see my screen?
No. Okay.
Hello, dear participants. I am Mehmet Karahan. I am a PhD student at TOB University, Electrical and Electronics Engineering Department. Our presentation topic is moving object detection and counting in traffic with Gaussian mixture models and vehicle license plate recognition with Previtt method. Here is our content. Detection and counting of moving objects and recognition of license plates are important process in traffic surveillance. In our study, moving object detection and counting and license plate recognition algorithms are explained. Gaussian mixture models are used to detect, track, and count moving objects in a video sequence. This algorithm shows the total number of moving objects on left corner of the processed video frame. Previtt operator and optical character recognition are used to recognize vehicle's license plate. License plate recognition algorithm can recognize license plates of different types of vehicles in different positions without any character limit. Moving object detection and counting algorithm is tested using different videos of moving objects. Then license plate recognition algorithm is tested using various photos of different types of vehicles. It could be evaluated that moving object detection and counting algorithm easily detects and counts the moving objects, and vehicle license plate recognition algorithm clearly recognize license plates of cars. In this section, foreground detector based on Gaussian mixture model, which is used to detect and recognize moving objects in real-life video sequences, is explained. Foreground detection is main technique in computer vision and image processing area, whose goal is to determine differences in image sequences. Foreground detection consists of techniques that analyze video sequences recorded in real time by a camera, and it distinguishes foreground from background based on differences occurred in the foreground. This technique offers fitting a Gaussian probabilistic density function on the latest n frames to prevent fitting the probabilistic density function from scratch at every frame time t. A moving average is determined. The probabilistic density function of each pixel is defined by mean mu t and variance sigma t square. Every pixel is assumed as background at initial condition. The below equations represent initial condition. It presents the pixel intensity value at time t. To avoid background change at each frame t, each pixel's mean and variance should be changed as below. P defines the temporal window size, and it is required to fit a probabilistic density function. Its value is generally 0.01. D represents the Euclidean distance from mean to pixel value. If pixel's current intensity is in the some confidence interval, the pixel described as background, and its distribution's mean is described in 6 and 7. K represents the threshold parameter, and its value generally equals 2.5. A larger K value leads to a dynamic background. A smaller K value rises probability of transition from background to foreground because of more delicate differences. Blob analysis object is used for further filtering the detected foreground by rejecting blobs. Blob analysis detects regions in the digital image which differ in terms of color or brightness compared to surrounding regions. Convolution is the most used method in blob detection. Blob detector depends on the Laplacian of the Gaussian. Given input image fxy is convolved by a Gaussian kernel to obtain a scale space representation at a certain scale t. The below equation represents the scale space representation. After the Laplacian operator is applied, below equation is obtained. Multi-scale approach is required to capture automatically blobs of different size in image domain. Scale normalized Laplacian operator is used to get a multi-scale blob detector. The equation below represents the scale normalized Laplacian operator. The structure of moving object detection and counting algorithm is explained below. Algorithm starts by obtaining initial video frame. Moving objects are segmented from background. Foreground detector initializes Gaussian mixture model. Blob analyzes object filters detected foreground by rejecting blobs. Moving objects are highlighted using green boxes. The number of moving objects is displayed on left corner. License plate recognition with Previtt method and optical character recognition. A Previtt method is used to detect edge of the license plates in images, and optical character recognition is used to recognize alphanumeric characters in license plates. A Previtt method is used to detect edges in image processing. It depends on convolving image with a small and integer value filter in the vertical and horizontal aspect. Previtt operator uses 3x3 kernels, and they are convolved with source image to obtain approximations of the derivatives. In equations, A represents original image, Gx and Gy represent two images, which at each point includes vertical and horizontal approach. And star describes two-dimensional convolution. Gradient magnitude is calculated using following equation. Direction of gradient is given in the equation below. The aim of optical character recognition is to achieve modification or conversion of handwritten text, printed or scanned images into a digital format for further processing. Optical character recognition technique recognizes each alphanumeric character with help of letters and numbers stored in database. Numbers from 0 to 9 and letters from A to Z are stored as data sets in database. After detecting the age of the license plate, the algorithm uses database to recognize letters and numbers on the license plate. Figure 1 shows the alphanumeric characters stored in the database. steps of vehicle license plate recognition algorithm are explained as below. Input image is converted to the grayscale image. Edges of the license plate are detected. License plate area is cropped from rest of the image. The letters and numbers on the license plate are identified using the optical character recognition method. Recognized license plate is shown as a figure in MATLAB software. Experimental results. In this section, experimental results of moving object detection and counting algorithm and vehicle license plate recognition algorithm are presented. First, examples of algorithm that detects and counts moving objects in a video are given. The figure 2 and figure 3 gives the experiment of moving object detection algorithm. Here you can see a man who is walking on a pavement and moving cars in the video frames. The algorithm displays the total number of moving objects on the upper left side of the video frame. In figure 2, the number 3 indicates the total number of moving objects in the upper left corner of the video frame. In figure 3, the number 5 indicates the total number of moving objects in the upper left corner of the video frame. Second, the examples of license plate recognition algorithm are given. By using license plate recognition algorithm, license plates of different types of vehicles such as cars, vans, buses, and motorcycles can be recognized. Figure 4 shows the front photo of the car, and figure 5 shows recognized license plates of the car. Figure 6 shows the side photo of the car, and figure 7 indicates recognized license plate of car. These results suggest that the algorithm successfully recognized license plates in different positions. A license plate algorithm was also tested on different types of vehicles. Figure 8 shows the rear photo of a van, and figure 9 shows the recognized license plate of the van. Figure 10 represents the public transportation bus, and figure 11 shows the recognized license plates of the bus. License plate recognition algorithm was also tested on a motorcycle. Typically, motorcycle license plates are the square in shape and their dimensions differ from the other vehicles' license plates. Figure 12 shows the rear photo of a motorcycle. Figure 13 proves the algorithm successfully recognized license plates of the motorcycle. Above examples prove that the novel license plate recognition algorithm can successfully recognize license plates in straight and inclined positions without any character and shape limitations. Conclusion. In this study, two main algorithms about traffic monitoring and safety are discussed. The first algorithm detects, counts, and tracks moving objects in traffic, and second algorithm recognizes license plates of vehicles. First algorithm that detects and counts vehicles uses Gaussian mixture models. This algorithm first detects moving objects and follows them as long as they are in motion by enclosing them in a green frame. Then it indicates total number of moving objects in video frames and displays it in the upper left corner. The trials have proven that algorithm can successfully detect vehicles and pedestrians in traffic and displays total number of them. Secondly, license plate algorithm developed using Previtt operator and optical character recognition is explained. This algorithm can detect license plates of cars, minibuses, buses, and motorcycles. The algorithm was tested by using photographs taken from different positions of different type of vehicles. Experiments show that algorithm successfully recognize license plates of different vehicle types in different positions. It has also been observed that it can recognize country code on the left side of the plate and small writings on the bottom of the plate without any character limitations. It is clear that using these two algorithms make significant contribution to traffic safety compared to conventional traffic monitoring systems. Here's our references. Thank you for your listening.
Thank you for presentation. Next presentation, dear Khalid Ali. Khalid Al Ali.
Yes.
Okay, you can start.
Hello everyone, can you hear me?
Yeah.
Yes. Okay, hey everyone. So our presentation is titled as Sustainable Practices in Construction SMEs, Small Medium Enterprises in the United Arab Emirates. a scoping study. So we will start with showing you the rationale of this paper and the aim and objectives, background info for our points, and then further on the key findings from literature. After that, we'll show our methodological steps and then the results and key findings. So for the rationale, the construction industry is picked because it is one of the main consumers of resources of raw materials, and it contributes massively to the carbon emissions. And as for the small and medium enterprises, they have a large contribution to the environment, social, and the economic profitability. And it is estimated that the number of SMEs worldwide is around 212 million in the year 2020. And in terms of sustainability in construction, the awareness of sustainable development is progressively being adopted internationally by large construction companies. However, for SMEs, they face complex issues to implement sustainability in terms of maintaining cost control, preserving efficient energy consumption, implementing of new technologies, and maintaining effective processes with their suppliers. Now, for the aim and objectives, the aim for this paper shares the results of a scoping study that explores and identifies the main pillars of sustainability within the construction industry to evaluate the levels of their utilization within the UAE construction SMEs, and assesses the stakeholders' perception of the factors that are most likely to contribute to practices within the SME of construction companies in the UAE. And we have three objectives. First one is to develop an understanding of the important pillars of sustainability for construction industry from the literature. Number two is to evaluate the level of sustainability practices adopted by SMEs in the UAE through a scoping study. And finally is to assess the most important factors of the sustainability pillars from the stakeholders' perspective using AHP analysis. So just a brief background, the concept of sustainability applied numerously in the field of construction, and they have effect on all of the activities during any construction project. So implementing sustainability contributes in enhancing the quality of life and preserves the scarce resources. And the sustainable construction, as defined by the United Nations Department of Economic and Social Affairs, it is the process that provides sufficient performance with minimum negative impact on the environment at the same time as emboldening social, cultural, and economic improvement locally and globally. And as you know, the SMEs in construction industry, they are defined as independent small firms that have a small number of employees, and it differs from one country to other. And from this figure, we can see that the number of SMEs are continuously increasing for the past 20 years. So it is important to have a study on the SMEs in the construction industry. So for the key findings from the literature review in the paper, the importance of sustainability is shown, which focuses on the importance of the implementation and sustainability developments contributes to the economy and protects the environment. For the role of SMEs in the construction industry, research shown the important role that SMEs play within the worldwide countries. The fact remains that ambiguous in terms of their role in sustainability indices and how they perform. The three main pillars also of sustainability have been outlined, and the indicators that will be used to further evaluate the SMEs will be shown. The main three pillars are the economy, environment, and social, which has different kind of indicators, which will be shown further in the next slide.
So the underpinning indicators that we have found for the sustainability practices here in the UAE, as for the SME construction companies, falls, as previously mentioned, with the economic, environmental, and social pillars. As you can see here, within the economic indicators, we have validated that the tax, economic preference, procurement practices, anti-corruption, economic development, as well as market presence was within the economic pillar. And as for the environment, the green buildings, the materials used, environmental compliance of these companies to strategic regulations in the country, quality of air and atmosphere, supplier environment assessment, waste emissions, energy intensity usage management, water efficiency unit usage, and biodiversity. Now, as for the social indicators, the labor and management relations, freedom of association and collective bargaining, marketing and labeling products, occupational health and safety factors, socio-economic responsibility, diversity and equal human rights, supplier social assessment, local communities, training and education, forced or compulsory labor, non-discrimination, human rights, local communities, so employment, child labor, security practices, and customer privacy. So these were the indicators that were found and validated for the sustainability practices. Later on, the methodological steps that were used includes multiple steps to fulfill the aim and objectives that were presented in previously. So first, starting with the literature review about the sustainability indicators, usually from the papers, from websites, from researched, reviewed articles. And then we have moved to the semi-structured interviews here in the UAE by validating and tailoring these indicators in terms of the UAE construction sector. And then after that, these were ranked based on their compliance to sustainability requirements using a semi-structured interview, which were conducted with 4 experts as seen from this table from the construction industry here in the UAE. And then they have been analyzed using the analytical hierarchy process to rank and draw pairwise comparison of the validated indicators in terms of their importance to the compliance of SMEs in the construction sector in regards to sustainability. This, however, furthermore, this will open the door for further research in terms of the maturity model. So basically, the weight percentage from each indicator on the AHP will assist the research to determine at what extent should a particular indicator extend through the development of the maturity model, which is the future aim actually of this project. So our result and key findings from the interviews, the participants selected interviews were experts, as mentioned previously, in leading construction organizations in the UAE. And these are the predetermined questions that were set for the experts. So basically, for starters, how the sustainability implementation has an effect on the economic, environmental, and social aspects in the UAE in general. All the interviewees agreed on the impact that sustainability implementation in the construction. They all agreed that they have a positive and negative impact. The interviewees also were asked regarding, based on their experience in the construction, do they believe these indicators are relevant to the sustainability construction practices in the UAE? And it was concluded that all 6 indicators under the economic sustainability are relevant, whereas the environmental sustainability, the experts added 2 more indicators, i.e. the energy management and pollution. And lastly, for the social sustainability, the expert identified only 12 indicators out of the 16 research and during the literature review part to be relevant to the sustainable construction practices. For the last question, the interviewers were asked to rate the indicators under each pillar, from 1 being the minimum compliance to sustainability requirement, and maximum number being the highest compliance. So the findings were summarized in this table, as you can see, for each indicator within each pillar. So for the social sustainability, as you can see here, the socio-economic responsibilities and the freedom of association and collective bargaining had a 100% ratio that, yes, they have an impact on the social sustainability of the companies. And for the economic sustainability, you can see that the tax, the economic development and economic preference, as well as market presence, held the highest yes ratio in terms of the relation of these indicators to the economic sustainability of SME construction companies. In terms of the environmental sustainability, however, you can see that the green building, the biodiversity, held the highest percentages in terms of relevancy to the environment sustainability of SMEs sustainability practices in the construction industry. Moving on, as you can see here are the final findings. The economic indicators, the highest was the procurement practices. Environment indicators, we had environmental compliance, emissions, waste energy intensity usage management, energy intensity usage management. And in terms of social indicators, we had the highest occupational health and safety, socio-economic responsibilities, training and education, and local communities. These indicators were actually considered as the basic requirements for the SMEs in the United Arab Emirates in the construction industry as a basic requirements to sustainability practices. So these were our final findings. And in conclusion, having identified these factors, and because the challenges that SMEs usually in the United Arab Emirates, especially in the construction sector, they face some limitations in terms of resources. These factors were identified as basic requirements for any SME in the construction industry within the UAE, if they are having in their agenda to achieve sustainability for a long period of time. It is recommended to have these factors in place, and therefore it is recommended to adopt a maturity tool that will allow these SMEs to monitor their performance and status. This scoping study was conducted to identify the indicators in the construction industry, and they were validated and tailored to the construction industry. Now, finally, this will open the door for future research to propose maturity models for the SMEs, having these indicators in mind, especially from the construction sector in the UAE. And that would be the end of our presentation. Thank you so much. If you have any questions, please do ask.
Thank you for presentation. Next presentation, dear Mehmet Mücahit Kaya.
Okay, I will present my screen.
Yeah.
Can you my screen? Can you see my screen?
Yeah.
It's now
No
okay.
problem.
Okay. Hello, I am Mehmet Mücahit Kaya, and I am a mechatronics engineer, and I graduated from the Turkish German University. Today, I will present our TÜBİTAK 2209B project. It's deep learning based vehicle-to-vehicle see-through system with auto start function. And this will be outline of the presentation. Today, I talk about these topics. And what's the problem? Problem is restriction of the driver's field of vision. And as a solution, increasing the driver's field of view by providing image transfer with V2V communication. And as a research, according to average of 2010, between 2010 and 2019 data, 1.78 travelers die per billion passenger car kilometers in Germany, and in 2017, 88% of accidents are caused by driver error, and number of driver errors while overtaking in accidents with personal injury in Germany in 2021 is 11,055. And as a solution should be offered to the problems that lead to overtaking accidents. And what is our objectives? Transferring the camera images of the vehicle in front to vehicle with a restricted field of view. Thus, we aim to accident prevention and acceleration of the traffic flow, driver and vehicle safety, and increase of the driving comfort. how the possible video streaming? It's possible to share the driving angel with other vehicles through the camera in the vehicle. It's thought that the image sharing will be done uninterruptedly as soon as the vehicles are within the communication range. Thanks to the AI-assisted auto start function, it's possible to display this image on a screen to the driver who has driving restrictions. And communication. The image of the camera is encoded with GStreamer and transmitted via the port specified with real-time transfer protocol, or RTP. Transmission of the broadcast on the same frequency as the rear vehicle RX with Wi-Fi broadcast, and Wi-Fi broadcast is open source software. And the rear vehicle follows transmission of the vehicle in front and decoding the transmission from TX with RTP, transmitting the image on the screen. And here is a communication flow diagram. We used in this part SST MobileNet as a vehicle detection, which is a convolutional neural network. This computer vision technique that predicts objects in an image or videos, and you can see detect object, detect track, and how to diagnose visual field restriction. This calculation will be used. To trigger the auto start function when driving at 30 km/h. The safe following distance must be at least 15 meters. At this distance, the bounding box dimensions obtained by object detection will form the basis of the calculation. It has been experimentally determined that the vehicle detected at the safe tracking distance occupies an area of 8,861 pixels on the image with a resolution of 640x 360 pixels. Thus, it's assumed that the viewing angle is restricted when a vehicle detected on the image occupies 1/26 of the pixel area, and you can see our calculation and our formula. Here, auto start function algorithm flow chart. The auto start function is as follows: a vehicle recognition algorithm. It's possible with SST MobileNet V2. Is running continuously in the system of the vehicle behind. If a vehicle is detected, an image processing algorithm is used to determine how much the vehicle obstructs the field of view. The algorithm will be called diagnosis of the visual field restriction. If an obstacle is detected above the allowed limit, image transmission is initiated. General overview like this. System architecture can be summarized with this flow diagram. First of all, auto start function and rear car algorithm and front car. Hardware architecture hardware architecture consists of two main baseline. One of them is mounted on rear car and the other is on front car. Camera and single board computer is used in front car. Front car it just as capture the image and camera and a single board computer is used in front car, just as to capture image and to transfer front vehicle when it connects a car found in connection range. Moreover, hardware topology is based on two single board computer. One of them provides more graphic processing. It's Jetson Nano. Graphic processing computation, which is required for vehicle detection algorithm and auto start function, and displays the image received from side restricting vehicle, whereas the other one communicates with other vehicles and gather the image transferring to single board computer with GPU. And in order for the developed system to be applicable, we design a prototype, and the prototypes was realized with 3D printer, produced with the 3D printer. And here is our demo video about our tests. Now detect a vehicle and it will connect front car. Now it's connect front car. Now rear car safely overtake front car. And conclusion and evaluation. Artificial intelligence algorithms are used to automatically transmit the image to driver, and automatically activated system when the side angle and distance are restricted due to vehicle in front during overtaking. RGB data with 60 FPS in 1280 x 720 pixels was transferred over the Wi-Fi connection without any problems in current circumstances. And vehicle-to-vehicle communication should be robust under all traffic conditions. Improve the accuracy of the algorithm that triggers the image transmission by supporting it with optical methods. And that's all my presentation. Thank you for attention.
Thank you for presentation. Is there any question? Okay. Dear Dilibal?
Yes, I am ready.
Okay, you can start.
Can you see my presentation?
Yes.
Okay, great. Hello, my name is Chennai Dilibal, and I'm currently connecting from Dartmouth College in the US. I worked on this paper in collaboration with my colleague Yalchin Tur from Stanford University, and our presentation topic is the implementation of Develop Asantam Smart Healthcare System in the Metaverse. Firstly, I would like to talk about the term metaverse, which has received immense popularity after the unfortunate COVID-19 pandemic and the release of virtual and augmented reality technologies that further the capabilities of 3D virtual environment. This newly formed field of mixed reality provides efficient and effective ways to receive medical service remotely, which we implemented into the healthcare platform. In this study, we propose to use Metaverse as a tool to embed the Asantum Smart Healthcare platform into. Metaverse has also the components of artificial intelligence, machine learning, augmented reality, virtual reality, Internet of Medical Things, and big data blockchain infrastructures as seen in the illustration. Moving on, I would like to also introduce the various different healthcare-based application areas that the metaverse could be adapted into. Since this is a highly advanced, novel, and newly published technology, its uses may vary and could be implemented in many more subfields. As you can see, there are various forms of application, which are shown here as preliminary and clinical examinations, surgery simulative environments, medical training and education, telehealth-related teleconferences, and mental health-related sessions or resources. As I said, plenty more application fields could be added to this list. Here we see the surgical simulations on the picture on the right. Continuing here in this illustration, we have the three main components and their subcomponents. As seen, we have the telemedicine and telehealth component, which opens the door for digitalization transformation of healthcare. Their subfields are, as seen, are remote examinations and cybersecurity protection, which I will further explain in the upcoming slides. Also, we have the other main component, which is wearable biomedical devices. This component serves to accurately detect and provide medical records in real time to physicians and patients. In our platform, we use IoT-based wearable devices to capture and collect more detailed data and store in the cloud storage. The last but certainly not least main component is the metaverse. This component is actually the part that we plan to embed the first two components into. The metaverse has the subfields of artificial intelligence, augmented reality, and interactive digital spaces, which refers to mixed reality. On this slide, we would like to mention Asantum. The primary objective of Asantum healthcare system is to digitalize the way of examination and telecommunication between doctors and patients through the cloud-based platform, regardless of their physical locations, in real time. The established healthcare system works by pairing with both smart health platform and wearable biomedical devices, which is known right now as mobile XMI device, to serve as a digital hospital that provides both patients and doctors personalized experiences for medical examinations. Additionally, here we have the link for further details regarding the Asantum mindset and website. Next, we have the wearable biomedical devices. Wearable devices are products controlled by electronic components and software that can be incorporated into the human body. Many wearable devices can be integrated in the smart healthcare system platforms. These devices in the proposed system serves to provide accurate medical data that gets stored and shared with doctors to be used in their real-time examination. Our system actually works with the mobile XMI device implemented. This device is used in the teleophthalmology field, where an ophthalmologist can examine the patient's eye remotely. Some examples for other devices are seen here, such as smart watches, smart glasses, biomedical sensors, and many more. Another important crucial aspect is the security and protection of the medical data in the metaverse. This is a very important aspect of the future applications of technology in various scenarios. Ensuring security in cyberspace requires new protocols against any type of outside-based threats. Especially in healthcare, when individual patients' medical data is confidential information, there has to be the advanced measures against cyber threats. Furthermore, the blockchain infrastructure of metaverse is highly attack-prone, in which the risk of social attacks is very high. Cybersecurity and the medical data privacy are two challenging steps for a secure implementation of metaverse-based smart healthcare systems. Furthermore, in this slide, we can see other features of the security aspect, which are cloning avatars to hide the patients from being targeted, creating private copies of public spaces for secure interaction between patient and the doctor, blockchain application, which we'll further discuss in the upcoming slide, And these are the significant tools which can be used for the security purpose of the metaverse technology. One of the significant methods that I just mentioned to secure asynchronous medical records is to apply the blockchain structure to hash and validate each block of patient medical data on the healthcare platform. Since each device carries a transaction history, in order to manipulate in medical records of a patient, every data recorded on each device should be changed in the same manner, which makes it difficult to interfere in a large device network. Here we see the system architecture with the blockchain on the illustration. In conclusion, in the study, the implementation process of the embedded Asantam smart healthcare system in the metaverse architecture is systematically investigated to clarify feasibility of the Asantam smart healthcare system in metaverse with potential concerns and limitations. The Asantam smart healthcare system architecture with cloud-based data storage and edge computing layers are clearly determined with the integration of wearable biomedical devices and mixed reality tools. In addition, possible solutions such as a blockchain method for the security of the patient's medical data are offered for a safe and secure smart healthcare environment. To standardize the doctor and patient interface in smart healthcare system layers, studies should continue in different medical branches with privacy concerns. Additionally, further experimental case studies should be conducted in order to determine the advantages and disadvantages of the smart healthcare system in the metaverse. Thank you for listening.
Thank you for presentation.
Thank you.
Welcome. Next presentation, dear Mustafa Muhammad. Dear Nabil.
Yes. Abir Nabil.
Yeah.
Yeah, okay.
Okay, all presentations were completed.
Okay.
Thank you for contribution. See you in the next organization.